Awesome. Good morning, everyone. My name is Chadwick Strange. I'm head of product at SKALE. Really excited to be here at ETH Portland. I haven't been here to the city yet, so this is the first time I'm here, and really excited to be here. Really excited to present to you SKALE and how to work with SKALE. Let's get into it. So today I'm going to start off with what is SKALE? What is SKALE Network? What are the features that SKALE Network provides? I'm going to go through how to deploy on SKALE. We have several amazing features that we've just released, and so this will be the first hackathon that we've provided these features to hackers. Then I'll go into projects building on top of SKALE, and then I'll close with talking about bounties. So what is the SKALE Network? SKALE is our mission is to empower Ethereum dApps to scale smart contracts in a secure, reliable, cost-effective manner, or as I like to say, UX-optimized manner with Ethereum native sidechains. I'll go into a little bit more detail about what Ethereum native is, but as a high-level takeaway, we have endpoints. I'll give more information and QR codes later in this talk, but there's an easy way that you can get endpoints at this address. And because we're built on top of Ethereum and we're built with Ethereum in mind, you can use all the Ethereum tooling that you normally use in deploying your contracts to Rinkeby or any other Web3 compatible network. So that includes Truffle, Web3, Hardhat, Ethers. We support all the Web3 custodial wallets or non-custodial wallets. We also have a native bridge that's on each chain that allows transferring of assets such as ERC20, 721, 1155 between Ethereum chains and any SKALE chain, and as well between any two SKALE chains. And that's an important takeaway I'll talk about in another slide. SKALE is a multi-chain network. It's a scaling network where we have hundreds of chains available for dApps to run on and to scale on. And we have a lot more that works with Ethereum tooling as well. So what does this mean? At the heart of SKALE is this idea of randomness, rotation, and incentives. And so SKALE Network is a network of many validators or many validator-run nodes. We have about 52 validators supporting the SKALE Network, running over 160 nodes. And collectively, each node requires SKALE token staking, so it's backed by roughly 3.5 billion and staked into the network. So these nodes are active and operating on the SKALE network, and when a node joins the network, it's actually interacting with the Ethereum blockchain. We have a set of contracts on Ethereum called SKALE Manager, and they orchestrate the logic of the network. They manage the network. It's like a network within the network. So as a dApp developer, when you come along and you say, hey, I need a quick way to scale my Ethereum application, you're basically requesting a SKALE chain from SKALE Manager, and SKALE Manager looks into the network and it says what nodes are available, and it selects 16 random nodes out of that set of 160 nodes. And out of those 16 nodes, it forms a blockchain. So this is an endpoint that's specific to your app that you can use to deploy your application, and all your users will be transacting with this application. This is critical because we all know Ethereum is an amazing, massive network that runs about 20 transactions per second on average. But this bandwidth is shared with all the dApps, all the users that are hitting that network. With SKALE, it's a multi-chain architecture, so each chain powers a dApp in that ecosystem. And so when you have a SKALE chain, that's 60 nodes that are supporting that SKALE chain. And behind this, underneath the hood, is a consensus engine. It's an Ethereum-compatible client called SKALE-D, along with BLS threshold cryptography that enable these nodes to work together and in concert with each other. And then on each SKALE chain, there's another set of features. It's not just a blockchain. It's also a storage layer. So we have a native file storage protocol built into your SKALE chain where you can store assets and files. You don't need to go to IPFS to persist a node to get your files served over the Web3. You can store your files natively on the same SKALE chain that you're deploying your dApp and serve those files natively from that endpoint. And then again, on each SKALE chain, there's a native bridge that allows transferring of assets, and so on and so forth. And then over time, these nodes are swapped out with other nodes. That way, you're preventing collusion over time. The validator set over time could learn that it's supporting maybe a $1 billion dApp. So we have this random rotation that nodes can swap out, join the network. They then basically catch up with the network state and then begin transacting with the other nodes. So it's a very powerful system. And again, it's a network of app-specific blockchains. So as a dApp developer, if you're running a decentralized exchange or a blockchain game, you're requesting a specific skill chain from the network that's provisioned to you and your community. And these skill chains run very fast, roughly sub-second block times. They can run up to 2,000 transactions per second. They run full state contracts. It's not just scaling token transfers. It can actually pack a huge bunch of EVM transactions or EVM complexity and run that on your skill chain. And that's because in previous hackathons, we've shown that you can take a machine learning protocol, put that into a Solidity contract, and forward propagate data through a model, and then have that all executed on the blockchain. So it's very powerful. It doesn't just scale token transfers, it scales EVM. And then as well as a messaging layer, and this is the IMA bridge. We're about to launch what we call Scaleverse. This is like the second generation of our blockchain system. And there's a key feature that we're providing that's enabling this system. As I said before, we have this native bridge that allows transferring of tokens from Ethereum to Scale. And that bridge it works with all token standards. And it's a polyolithic bridge, meaning that every dApp that's running that bridge can customize a bridge to their chain. So you can expand the bridge to use other token standards, and you can set the bridge up and configure it any way that you want. So you're not just using a single bridge between one or two chains. It's a bridge that's customized for every chain in the network. And what we're about to launch is a way to send messages from any two Scale chains. And these transfers happen very fast, about 18 seconds to resolve a transfer from leaving one chain and then being executed on the next chain. And with scale chain to scale chain transfers, these transfers happen in a gas-free environment. So again, the way that we look at this is we have the mainnet partner ecosystem. These are dApps that are on Ethereum, and they can then hook up the bridge from Ethereum to Scale. And part of these abstractions we call Scale hubs. They're service layers that can provide access or data for other chains in the network. And the way to think about this is you could have an exchange hub, an NFT marketplace, a liquidity ramp, or other service layers that act as hubs. These are scale chains that are just service layers that provide data and services to many other chains in the network. So a play-to-earn game or a blockchain game might need a liquidity on-ramp or a DEX. They don't need to build that out themselves or have it deployed on their chain. They can link that to an exchange hub within the Scale network and then be able to transfer tokens in a gas-free way to the liquidity hub to allow users to exchange and swap to other tokens. Same thing applies to an NFT marketplace. You don't need to deploy that on your chain. You can now mint tokens on a play-to-earn game chain and then send those tokens to an NFT marketplace with an 18 seconds resolution time and a gas-free way to then sell that on a marketplace. So you can see that this is expanding the ability for Scale hubs to power other dApps in the ecosystem and to allow scale chain to scale chain transfers to allow this information to power other applications in the Scale network. How to get a scale chain? It's very easy. There's this QR code. I'll be showing this QR code at the very end of the presentation. But if you go to this link, it will provide you with a faucet. It will give you, there's 4 scale chains available at this conference for you to deploy onto, along with all the documentation. And we have about $15,000 worth of prizes that we're giving out at this hackathon. Now, what are the things that you can do on Scale? I'll go into a lot of these specifically, and I'll probably jump to some videos to show you what this looks like. Everything built on a scale chain operates in a gas-free environment. We have a native token called SFuel, but there is no economic value to this token. This token is used and provided to users to allow them to access and conduct transactions, but there's no economic value to this. And the reason why we have this is you do need SFuel to prevent DDoS attacks from your SKALE chain. But if you request a SKALE chain, you're provisioned a massive amount of SFuel that then you just send to users as they onboard. So now you have a UX optimized blockchain where users don't have to go to some DEX and then get some ETH in order to do transactions. So long as they have SFuel in their account, they can conduct as many transactions as they need and then be able to top up SFuel as they use your chain. We have a 160 million block gas limit, so you can pack a lot of stuff in our blocks, again with sub-second block time resolution. We have a lot of different optimizations. A small one is, the Ethereum blockchain has about a 24 kilobyte code size limit. You can actually change this and specify this for each SKALE chain. For the hackathon, we have 32 kilobyte code size limit. And then I'll show you specifically these features. We have native file storage. We have a node library that allows you to interact with file storage and upload files. So you can do things like hosting web servers, which I'll demo to you, and put assets natively on your SKALE chain. We have a new feature called a random number generator endpoint. We all know for Solidity devs, getting a good source of entropy that's unbiased is very difficult. There are a lot of good products out there. I think you'll love SKALE's random number generator endpoint. That's based on the BLS threshold cryptography that's at the core of our system, and I'll demo that in a second. We also have a native Oracle API that's built into every SKALE chain, so now you can make JSON RPC requests to get data off-chain and bring that on-chain and provide that data to smart contracts. And then we have the native IMA bridge, which I'll also demo. So let's get into it. Let me switch and show you the file storage demo. So this is a bit truncated, but I'm basically showing you, building a decentralized website. So what I'm going to be doing here is building a project, importing some environment variables, installing npm, and setting up my website. Installing some libraries, so we have file storage.js as the native library for supporting file storage. Let me skip ahead. I'm building a test folder and then adding in my HTML files, so I'm just making a basic boilerplate website. I'll add some styles. So here are my website files. And then I have this file storage script. And this is basically going into that test folder, uploading the files using the file storage.js library. And then I'm executing this. In the back end, my environment file has already loaded the SKALE chain endpoint. So what it's doing right now is it's uploading those files directly to the endpoint, and those files are recognized by the SKALE client as special files to be placed in the storage layer. And so that's being sent to the blockchain. It's being recognized as files being uploaded, and then it's storing it in the native storage layer on each of the nodes of the SKALE chain. And then I'm loading this. On each SKALE chain, there's an Nginx server. We call it like a Web3 server. So now we can serve files natively on the web. So that's my SKALE endpoint, my SKALE chain name, and then boom, I've got my website that's being served. And each of those files being uploaded are being stored redundantly across all the other nodes in the network. So that was file storage. The next one I'll demonstrate is the random number generator endpoint. So right now I'm using Remix. I have this boilerplate contract here, and it's using a precompile at the address that's deployed. It's precompile on each of the SKALE Chain nodes at address 0x18. I'm compiling this in Solidity. I'm going to go to injected web 3. I got my endpoint loaded. I'm going to deploy this to the SKALE Chain itself. Again, you notice there was sfuel that popped up there in MetaMask, so I'm not paying anything. I just need sfuel to deploy those, that contract on Scale. And I'm hitting this function here called getRandom. And what this is doing is it's getting the current block. It's getting the threshold signature shares of the current block. Again, there are multiple nodes that are supporting the SKALE Chain, and every single block that those nodes sign using BLS threshold cryptography. So no one node can influence the outcome of that signature system. So that signature that's provided is then hashed and then provided as a return through this function. So I'm able to get random numbers for every block that's mined. So I think that's and then you can serve this obviously in Solidity to power games, power different parameters or different properties to your NFTs. So I think this is a very powerful system that's available here at ETH Portland to all the SKALE chains that are available. Next, I'll jump to the Oracle API. We just released this, but what I'm going to be doing is running an example script, and this is sending an Oracle JSON RPC request to the nodes. Let me pause here. This happens very quickly. What I'm asking is getting the server time at Binance. And when this JSON RPC request is received by the SKALE endpoint, this request is then broadcast to all the nodes powering the SKALE chain, which are typically 16 nodes on production. And then each of those nodes are individually going to this API and getting the response. Once the response is received, all the 16 nodes are waiting to come to consensus on whether the response that they get is in agreement. Then once that's done, the nodes sign. SKALE is Byzantine fault tolerant, and with BLS threshold cryptography, we only need 6 nodes at that point to provide a result. That means there's at least one truthful node out of the 16 nodes. So you'll see the signature set here. It's not all the signature from the nodes. It's just the nodes, the minimum needed to provide a truthful result. And so I'm getting the JSON response for that result. So it's very quick. It's very low level. You can modify this any way that you want and provide this result into Solidity. Let me see where we at here. And then the bridge. Hopefully this works. I set this up just a few minutes ago. But I have this sandbox here. And what you're looking at here is it's a demoing sandbox where I have a bunch of scripts that are binding into the IMA bridge library. And what I've done is I've deployed an ERC20 token on Rinkeby, and I've deployed that token on Scale. And so I've hooked it up to the bridge. I've mapped these tokens on either side. And I've minted these tokens on one side. So on Rinkeby, I have 99 of these tokens. And so I'm going to hit this deposit button, and what it's going to do is it's going to send these tokens to the IMA bridge deposit box on Rinkeby, and it's going to be picked up by the SKALE Chain IMA agent, and it's going to be transferred over to the SKALE Chain itself. So I'll hit deposit. Oops. Oh, it's too low. I thought that would happen here. Anyhow, I will have a backup video that shows this. This is a slightly different bridge, but this is showing, it's actually a bridge showing an NFT being transferred. So this is hooked up. I have a balance of 2 NFTs here on Rinkeby. I'm hitting the deposit button. We have the approved transaction. Skip forward, followed by the transfer. So you've seen 1 being taken out from Rinkeby. It's now mined on Scale. And then skipping forward, because I'm talking here in the video about the exit process. So I can hit exit, and that's removed from the SKALE chain, and that's being picked up by the agent and then presented to the Rinkeby network. And pending Rinkeby's wait time, then you should see this pop up. So now we have two. So I've shown a transfer from Rinkeby with a NFT token to SKALE, which happens very fast, and then the exit back, leaving the SKALE token and back onto Rinkeby. We have these sandboxes. We have APIs available for you at this hackathon. We have all these SKALE chains that are connected to Rinkeby, as well as two SKALE chains that are connected together, so you can play with transferring tokens between any two SKALE chains. Let's see, let's go back. Some projects that are building on SKALE. So we have we have many projects. One I want to talk about is Ivy Cash. They've made a mechanism where you can present a QR code that you can scan at different events. And as soon as you scan that QR code and it goes into your phone, it actually goes to a SKALE chain and mints an NFT in a gas-free way on that SKALE chain. So now you can integrate airdrops. You can now mint a bunch of NFT tokens at different events in a gas-free way and present that to users. So they've been using this for a while now, several months, and has been deploying this at different conferences and different events. And it's very fast. Hundreds of users can scan this QR code, and it will just mint immediately on the SKALE chain with the fast transaction times. We have another one that was launched just yesterday called the CLET name service. This is an extension of a human-readable cryptocurrency wallet naming service, which is built on top of SKALE. CLET is different than other name services because it's aggregating name services from across networks. So that includes Bitcoin, Ethereum, even Solana, and other networks. And what's happening here is that you can there's a browser extension that they built. So if you go to Etherscan and enter in a name that you've reserved on the CLET name service, it will resolve, if you're using Etherscan, to the contract or to the destination using Etherscan. Same thing with Solana block explorers, and same thing with Bitcoin block explorers. And how they're using SKALE is when you reserve a name using CLET, it's actually minting an ERC 721 record on SKALE. And so that way you can reserve names natively on the network in a gas-free way. And then we have Ruby Exchange, which is one of the liquidity providers. I only have a marketing video to show right now, but they're a gas-free decentralized exchange that will be launching soon on the SKALE network. You can then swap any tokens, perform any liquidity measures or liquidity pool measures in a gas-free environment and very quickly on a SKALE chain itself. So we're really excited what Ruby has built, and I think you'll love their UI. Let's see. Some cool things you can build on SKALE. This is only suggestions. With the fast finality, you can do lots of really cool things like media paywalls, authentications, oracles. We've seen this at other hackathons where people have built a paywall within a website. You can then post your tokens or post whatever you need to get access to that paywall. And you don't need to wait for that to be resolved. It happens almost immediately. So really solid UX with a gas-free environment and very quick, fast finality. With no gas fees, you can do NFT drops. You can integrate different mechanisms for DAO voting in a gasless way or any DAO governance done in a gasless way. And then SKALE can operate high throughput. At ETH Portland, these SKALE chains can operate up to 200 transactions per second. You can do a lot of interesting things. We've had a lot of dApp developers that have decided with immersive and AR, like a Unity game, that you can actually put all the positional elements as blockchain transactions on a SKALE chain, and the SKALE chain can support that. So it kind of opens up the design space that you can now do with Web3. We also want to announce we have a $100 million USD value ecosystem grant program for projects looking to build on SKALE, such as blockchain gaming or metaverse or NFT projects. So come find us at the booth. We'll give you more information about that ecosystem grant program. And then finally, the prizes. So again, 15,000 that we're dispersing out at this hackathon, 5,000 to a DApp that shows real-world impact with an opportunity for follow-up investments and grants, 5,000 to metaverse, blockchain gaming, and NFT projects, 2,000 for partner integrations. If you partner with any other of the other sponsors here, and then showcase that, that's $2,000 for that. And then a $3,000 pool for all teams that launch their product on a SKALE chain. So again, there's 4 SKALE chains available to you. If you show a deployment onto the SKALE chain, that's a pool prize for all projects for that. And I think that's it. Come find us at the booth. This QR code will give you all the information that you need to get a SKALE endpoint, to get free S-Fuel, and to reserve space in the native file storage layer. Thank you.